really picky about like how you enter these answers. So if you're watching this video because you got a bunch of parts marked wrong, just make sure you're using the vectors button off to the side because it won't take, typing in less than or greater than as an answer. But if you do a plus b, that means you add the like components. 4i plus 1i makes 5i. So that's our first component. And then the second component, 1j plus 11j makes 12j. Oops, and I close it. I just hit the vector button to make sure I'm using the symbols that they want. And then standard unit vectors, I tried to type in the letter I when I did this, but it's going to mark that wrong. Apparently you got to go down to vectors and you got to do that special letter I. Got to do their special letter I. Okay. And then if we're supposed to subtract, you got 4i minus 1i makes 3i. Oops, sorry, and this is component form, so gotta hit the vector button. So 4i minus 1i makes 3 for the first component, and then the second component, 1 minus 11 makes negative 10. Close that vector. And then standard unit vectors, we have 3i, so we got to use their special letter I, and then we subtract that by 10j. And I'm just going to verify this because this is the third time I'm trying to make this video and I haven't gotten used to WebAssign's notation. There we go. Okay. Verify that the vectors a, b, and a plus b satisfy the triangle inequality. Now, the textbook kind of goes into the triangle inequality and its origins, but the basic idea is that if you're trying to find the magnitude of two vectors, meaning the length of the sum of two vectors, that's always going to be less than the sum of the magnitude of the first vector plus the magnitude of the second vector. And you can see this really easy by just drawing a vector A, drawing a vector B that's coming from vector A. And if you were to add those lengths, that's definitely going to be longer than the line that goes directly to the endpoint. It's like with a triangle, if you are going from point A to point B, the direct line between those two is always going to be shorter than going out to like point C and then to point B. Okay, but the magnitude of A plus B, that just means you're supposed to add vector A and vector B, which we did up here. We got 5, 12, so 5i, 12j. And so the magnitude of this vector up here is the square root of the square of each component. So it's, get out of here, there we go. It's the square root of 5 squared plus 12 squared. So that's the square root of 25 plus 144. And it's the square root of 169, which is 13. So the magnitude of the sum of those two vectors is 13. The magnitude of vector A, that means how long is vector A. And that's, again, you could get this from the Pythagorean theorem too, but that's the square root of 4 squared plus 1 squared. It's the square root of 17, so let's type that in. Square root button, 17, and then vector B I'll do a little bit more quickly. 1 squared plus 11 squared, so that's 1 plus 121, that's 122, so that's the square root of 122. And then we could verify the triangle inequality there, right? If you take the square root of 17 and then add that to the square root of 122, that's 15.168. So the magnitude of each vector separately is always going to be greater than or equal to, it could be equal to in case they're the same, the magnitude of A plus B. Okay, A could be a 0, 0 vector, B could be a 0, 0 vector. That's how they could be equal to each other. But okay, verify the vectors that these also satisfy the triangle inequality. It's the same thing, whether it's addition or subtraction, that the separate components, magnitude of A plus magnitude of B, when you subtract two vectors, that just means you're going in a different direction. You're adding two lines to each other. That's always going to be that's going to be less than or equal to the length of just the direct line between the terminal point when you subtract A and B. So that's kind of just the explanation of what they're trying to get us to do here. We just need to calculate the magnitudes for each of these parts. So here's the vector A minus B. We already calculated that. So it's 9, the square root of 9 plus 100. So it's 109, square root of 109. And then the magnitude of vector A, we already have is square root of 17 from right above. And the magnitude of vector B is the square root of 122. And so the triangle inequality still holds, right? This is less than 13, so this magnitude is definitely going to be less than the sum of the magnitude of these two vectors. Determine the vector 10 times A, so we're just multiplying vector A by a scalar. So every component gets multiplied by 10, so that's 40i plus 10j. So we've got to use WebAssigns notation. 40i, comma, 10 for j. And clicking that button, deleting what I don't want. That looks, there we go. Guess you got to arrow, you got to use your keyboard to arrow outside and hit the vector again. I don't know, there's probably an easier way. And that's 40 with their I plus 10 with their j. And then negative b, that means you're multiplying by a scalar of negative 1. So instead of 1i plus 11j, now I've got negative 1i minus 11j. I think I got that. Negative 1i minus 11j. Yeah, and then standard unit vectors. Negative 1i minus 11j. And then determine the vectors 10a minus b. So that's 10a. And then this is negative b. So you could just, I guess, be careful with this one because you don't want to minus a negative, right? You're doing 10a minus b. So we already found out what 10a is. That's 40 comma 10. And then we're subtracting that by b, which is, so that's where the double negative, I almost did the double negative there. We're subtracting it by b. Or if I was to subtract it by this, I'd be subtracting it by negative b. So if you subtract the like components, 40 minus 1 makes 39. And then 10 minus 11 makes negative 1. And then standard unit vectors, that's 39i minus 1j. Okay, let's see if I got it all typed in right. There's a lot to type in on this question, so there's a lot that could go wrong. Okay, looks like that's it. So I think the big problem is just like using those right buttons in WebAssign.